Hi all, welcome back to my today's lesson on electromagnetic field, and the topic name is Introduction to Electrostatic Field and Coulomb's Law. Myself Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronic Engineering Department, Institute of Aeronautical Engineering, Hyderabad. So, what is the course outcome of today's topic? First, it will help make use of the Coulomb's law for obtaining force, electric field intensity due to line, surface and volume charge distribution. And it will help to recognize the basic nomenclatures of point charge that helps in characterizing the behavior of electrostatic fields. So these two are the course outcome of my today's topic. So before starting, what is electric charge? Electric charge is the fundamental and the characteristic property of any elementary particles. When we are telling anything, say we are telling in the air, there are some free electrons and this is called only charge. There are two and only two kinds of electric charge and they are known as the positive charge and negative charge. One is positive charge that is written by plus and negative charge is written by minus. What is the physical significance of the positive charge and negative charge? When we are thinking about the atoms have equal number of protons and electrons in it. The electrons are on the outer orbit and in the nucleus there is neutron and proton. If we want to draw this, if this is the nucleus, in the nucleus there is some positive charged particle which is known as the proton and there is some uncharged particle which is known as the nucleus. And outer side there are many orbits like this and we can find the electrons here. Electrons are negatively charged. Now when we give some potential or any power to these atoms, the electrons may come out or electrons may come in from outer side. If the number of electrons is more than number of protons, we can tell it as a negatively charged particle. And if the number of electrons, if the electrons go out from these atoms and number of electrons is less than number of protons, we can tell it is the positive charge. So proton number is always constant. Deficiency of electrons means positive charge and addition of electrons are known as the negatively charged. Next, two important things. Like charges always repel. If both charges are positive and both charges are negative and if they are nearby, the like charges are always repel. And unlike charges are always attract. These two are the basic properties of the charge. And charge can move but charge is conserved. What does it mean? We can move the charge from one point to another point, but the total number of a charge is always constant. And from here we got the conservation of charge. Next we got the conservation of charge. What is the meaning of conservation of charge? According to the conservation of charge, that charges cannot be created or destroyed, but we can transfer from one object to another object, or that is the amount of the charges in a closed path, in a closed system or closed path is always same. Charges cannot be created or charges cannot be destroyed. In a closed path, the number of charges is always constant, and this law is known as the conservation of charge. And on this, the Coulombs is given, the scientist Coulomb has given his law in the year of 1785, and according to his name, the law is known as the Coulomb's law. Coulomb's law is one of the important innovation in the physics, especially in the electrostatic, and it defines the amount of force between two stationary. We will only think about the stationary charge, electrically charged particle, and the stationary charge is known as the electrostatic. As it is the on the two charge, we can tell it as an electrostatic. So electrostatic, the Coulomb's law was first discovered by Charles Augustin de Coulomb in the year of 1785, and the law is according to his name, and it is also known as the inverse square law. So what is this law? According to the Coulomb's law, or already we have told, if two charges are there, the two charges will give some force on each other, and the force always works on the line connecting between them. The force always works in the line connected between them. If the two charges are like charges, means if both are positive or both are negative, if we have the like charges, both are positive or both are negative, both charges will repel each other. You can see the F12, the force on the first particle due to the second particle. F12 means force on the first particle due to the second particle, and F12 force on 1 due to 2, and it is going in the outward direction, means it is a repel force. Now if we think about this one, you can see it is written as F21. What is the meaning of F21? Force on second particle due to the first particle, and it is also outward because both are positive charge and they repel each other. Similarly, if both are the negative charge, F12 is also outward direction, F21 is also in the outward direction. But as if the forces are opposite, if the charges are opposite, one is plus, another one is minus, the force will work in between their connecting line, and we can tell F12 is equal to F21. Both are in the same opposite direction, means both are attractive force. So, and on the basis of the properties of the charges, Coulomb has determined that force is attractive if charges are opposite sign, and force is proportional to the product of the charges Q1 and Q2 along the lines joining with them. If one charge is Q1, another charge is Q2, and the force will, if it is positive and it is negative, so the force will be attractive force, and the force will work in along the joining line. According to the Coulomb's law, this force is directly proportional to the Q1 and Q2. Force is proportional to the product of the charges Q1 and Q2 along the lines joining them. This is his first rule. What is the second rule of the Coulomb? The force is inversely proportional to the distance between them. If this distance is r, so force is inversely proportional to r1, 2. So there are two main rules. Number 1, force is directly proportional to the product of the charges along the lines joining them, and number 2 is force is inversely proportional to the square of the distance between two charges. So if we just write the two equation together, we will get F12. So this is our F12, force on first charge due to second charge. Force on first charge due to second charge, it is 1 and this is our 2. So F12 is directly proportional to Q1 Q2 divided by R12 square. What is the meaning of R12? R12 means distance between 1 and 2. So if this is the proportionality equation. Now if we get the F12 and if we want to change the proportionality sign, we have to change it into the constant, and this proportionality constant is written by K. Now what is K? The K is the units of constant we can determine from the Coulomb's law. The constant we can get from the Coulomb's law, and the value of this equation is 8.987 into 10 to the power 9 is the value of the K. What is K? K is equal to actually 1 by 4 pi epsilon 0. What is K? K value is 8.987 into 10 to the power 9, or we can write it as the 9 into 10 to the power 9. What is the unit? Newton meter square Coulomb to the power minus 2. And what is the value of the K? If you write it mathematically, K is equal to 1 by 4 pi epsilon 0, and epsilon 0 is the permittivity of the free space. So we can write according to the Coulomb's law, F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. So this law is known as the Coulomb's law. And what is the value? What is epsilon? The permittivity of the free space, and its value is 8.854 into 10 to the power minus 12. So this is the value, and for any type of problem you have to remember this value. No need to remember of this value. K value is not needed to remember. You have to only remember the value 8.854 into 10 to the power minus 12, which is the value of the epsilon 0. So what is the, before telling the epsilon 0 is for the free space. Free space means vacuum or air. But if the medium is other than vacuum, what will happen? In that case, we can write F is equal to 1 by 4 pi epsilon Q1 Q2 by R square. Now, you may ask, what is the meaning of epsilon? Epsilon is the permittivity of any medium. What is epsilon? Epsilon is the absolute permittivity or permittivity of any medium. And what is epsilon? Epsilon is equal to epsilon 0 and epsilon r. What is epsilon? Epsilon 0 is the permittivity of the free space or the vacuum, and epsilon r is known as the relative permittivity or dielectric constant of the medium with respect to free space. And what is epsilon 0? Epsilon 0 means epsilon 0 and epsilon r. So this is the Coulomb's law in the scalar form. We can tell it is the Coulomb's law in the scalar form. Here we have not used any direction or anything. So it is okay for the lower the classes up to class 12. But when as an electrical engineer, you have to consider the direction of the force. So already we have discussed 4 maybe 2 types, either repulsive or attractive. So what will be the change if we think the direction of the force? Okay. Before that, there is a very small problem we will discuss. Two charges, 1 coulomb and minus 3 coulomb, are kept at a distance of 3 meter. Find the force between them. So, one charge is, according to the problem, one charge is 1 coulomb and another charge is minus 3 coulomb. So, both charges are not like charges, both charges are different charges. We can tell them as an, what is this? This is nothing but the attractive force, because both charges are different. So, this is the, and the force will work in according to their lines of force. Now, if we want to calculate the F12, what is the meaning of F12? Force on 1 due to charge 2. So, what is the formula? 1 by 4 pi epsilon 0. Why epsilon 0? Nothing is mentioned, mean we will assume. What we will assume? We will assume that the medium is air. 1 by 4 pi 0 Q1 Q2 by R square. So, if we put the value 1 by 4 into pi is 3.14, epsilon 0 is 8.854 into 10 to the power minus 12. Next, what is Q1? 1 coulomb. What is Q2? We will take only the magnitude. We will not take the direction of the charge. Is this positive or negative? We will not take. We will only take the magnitude of the charge. The other thing, the direction, the minus 3 coulomb only to tell it is an attractive type of force. Divided by what is this? This is the distance is 3 meters. So, this is 3 square. So, this is the formula. So, we already know this value will come 9 into 10 to the power 9. The value of 1 by 4 pi epsilon 0 is 9 into 10 to the power 9 into 1 into 3 by 3 square. So, the value is coming 3 into 10 to the power 9 Newton. Now, the important thing, Coulomb's law in the vector form. So, now we have to understand the direction. If this is the repel force or if it is the attractive force, what is the direction of the Coulomb's law? So, let's start. So, say this is one charge Q1 and the distance from origin is R1. This is the another point Q2 and the distance from origin is R2. And the distance between Q1 and Q2 we are writing as A12. What is A12? A12 is nothing but the unity vector. What is A12? A12 is nothing but the unity vector along the lines of force, along the lines joining the Q1 and Q2. And what is the meaning of A12? The force of 1 due to charge 2. So, when we are writing the equation, the force, what is the force on second charge due to first charge? We are calculating the force F2. What is F2? F2 is equal to Q1 Q2 by 4 pi epsilon R12 square. This is according to the Coulomb's scalar equation. Now, what is the direction? The direction is along the joining line, and the joining line is A, unity vector of the joining line is A12. What is A12? A12 means the vector, the line vector of the joining line R12 divided by the magnitude of the vector. What is the meaning of unity vector? If A is a vector and its magnitude is A, so this A by mod A is known as the unity vector. So here the main vector is the distance vector. the distance between 1 and 2. So the unity vector is the R12 mod of R12. So this is the A12. If we substitute the value here, what will happen? Let's check. So if we put the value, we can get Q1, Q2, 4 pi epsilon 0, R12 square. Now in the place of A12, we are writing R12 square. This is the vector, R12 divided by mod of R12. So if we minimize it more, what will be the value? The value will be R12 square and R12 will be multiplied and we will get R12 cube. So this is the vector form. Now if we think about the Q1, force 1. So what will be the force 1? Only change will be when if we are thinking about the force 1. The force of Q1 due to the charge Q2. The force on Q1 due to the charge Q2. What will happen? So everything will be same. F1 or we can write F12 equals to Q1 Q2 same 4 pi epsilon 0 R12 square. And now the force is not this direction, force is in this direction because force on 1 due to charge 2. So it will be A21. A21. And you can understand the direction has been changed. So we can write F2 equals to minus of F1. F2 equals to minus of F1. Forces have equal magnitude but opposite in direction. Now, what will happen if there are a lot of charges working on a point? So this principle is known as the superposition, principle of superposition. What does it mean? Say we have a charge Q1 here. This is our charge Q1. This is the charge Q2. This is the charge Q3 and this is the Q4. Here we use the orange color for positive charge and the blue color for the negative charge. So if we want to calculate the force on the first one, this is our first charge Q1. So what are the force working on it? The force due to Q4 plus force due to Q3 plus force due to Q2. So force for 1 means the force on 1 due to charge 4. Force 3 1. What is the meaning of force 3 1? The force on 1 due to charge 3. And what is force 2 1? The force on 1 due to charge 2. So all the force will be added and we can get the force on the first charge on the Q1. This is known as the principle of superposition. We have to calculate the force 1 by 1, F21. What is the meaning of F21? Q1, Q2 divided by R square. If the distance is R square into A21. Similarly, we can calculate the F31. We can calculate the F41. So this is the force on the charge is the vector sum of individual of all charges. Don't forget the word vector sum. We have to take care of the unit vector. So this is a simple problem I will discuss. So what is it is telling? A point charge 1 millicoulomb and 2 millicoulomb are located at there are two charges. this is 1 millicoulomb and another charge is 2 millicoulomb are located at the point 3, 2, minus 1. And what is the value? Minus 1, 4. Calculate the electric force on 10 nanocoulomb charge located at this is minus 2 millicoulomb, okay, located as 0, 3, 1. So 0 means this is our x-axis, this is our y-axis, and this is our z-axis. So what is the point? 0, 3, 1. Somewhere here, and the point is 0, 3, 1, and the value is 10 nanocoulomb. What is the meaning of nano? Nano means 10 to the power minus 9. Milli means 1 into 10 to the power minus 3. So we have to calculate the first electric force. So how to calculate the electric force? The procedure is very easy. We have to connect these 2 points and these 2 points. So this is one force and this is one force. If this charge is 1 and this is 0, this is 2. So first we have to calculate the force 1, 0. What is the formula? The formula is Q1 1 millicoulomb into 10 nanocoulomb divided by R square. What is, now we have to calculate the R. So when we are calculating the R, we have to think what is the starting point and what is the end point. What is the end point? 0, 3, 1. So what is its axis? 3 AY plus AZ. What is its coordinate? 3 AX plus 2 AY minus AZ. So if we want to calculate the distance, what is the formula of the distance? End point minus starting point. End point minus starting point. So we have to divide the O minus 1. O point, this is our O point, to 1 point. What is the value? So O point is 3 AY plus AZ minus 3 AX plus 2 AY minus AZ. So what is the line? Minus 3 AX plus AY plus 2 AZ. What is the length of this line? Already we have discussed many problems in our previous lectures. If you want, you can check the equations on the lectures also. 3 square plus 1 square plus 2 square. 9 plus 1, 10 plus 4, 14. So it is coming root 14. 10 into to the power minus 12 plus root 14 unit. Similarly, if we think about this one, due to the second, we can write it F20. So it is the 2 minus 2 actually into 10 to the power minus 3 into, what is the value of this 10 nanocoulomb? 10 into 10 to the power 9 divided by, again we have to calculate the distance. End point minus starting point. What is the location of this point? Minus x hat minus y hat plus, ax hat, ay hat minus 4az hat. So what is the location? 2 point minus 0 point. A 2, 0. I have missed one thing. I have not mentioned the direction here. It is A, 1, 0. Next, we have to calculate the A20. What is the first? We have to calculate the length. We have to calculate the length. How to calculate the length? End point minus starting point. And if we check all the end point and starting point, it will come minus ax hat minus ay minus 3y 4ay hat plus 4az minus az. End point minus starting point, It is end point minus starting point, so it is coming 3ay plus az minus ax plus ay plus 4az. So what is the value? Ax, so it is coming minus ax. This is also minus. Minus plus ay plus 3ay 4ay 4az plus 5az. So what is the value of this line? 25 plus 16 plus 1. 25 plus 16 plus 1. So it is coming root 42. So like this we can get the value of this root 42 whole square. Root 42 whole square. Q1 Q2 by R square. And the unit is So if we put the value, we will get the force value like this. What is the force value? F10 plus F20. F10 plus F20 is equal to total force. So this is the one very important example. We have to calculate the force individually, and the total force is the summation of the individual force. Next, we will discuss about the electric field. So what is electric field? According to the physicist, it is some imaginary lines of force. What is this? It is an imaginary lines of force. It is caused by an object from a distance away. So what is this? This is very tough. No, this is easy. What is this? If we want to bring one unit positive charge in any area, it is called the electric field. What is electric field? The area. The area is known as the electric field. See, in the overhead coils, we are thinking about the overhead lines. In the overhead lines, it is surrounded by the air. Now, the current is flowing and there is a very high voltage, high tension line, high voltage. What will happen? Due to the potential gradient, the air outside this area will be broken, and this is known as the electric field. The electric field is the area where if we put any charged particle, it will feel some force. So, what is electric field? Electric field is defined as the force acting on the test particle divided by the charge of the test particle. What does it mean? Electric field is nothing but the force acting on a test particle. If we keep any test particle in any point, it will feel some force, and this area is known as the electric field. And the electric field can be, and if we want to bring one unit charge from infinity to that field, we can tell it as the electric field intensity. Electric field intensity can be written as F by Q. What is Q? Q is the unit positive charge, the amount of charge to bring from one far point to a near point. So, what is electric field? Electric field, we wrote that the force per Q. What is the Q? Q means the amount of charge. So, we already know what is force. force is nothing but the K. If there are two charges, small q and capital Q, and the distance is r, so K, q by r square. So if we want to calculate the intensity due to the charge q, so force per q means it will come K by q r square. And what is K? K is nothing but 1 by 4 pi epsilon 0 q by r square. So if we want to bring one positive charge from infinity to one charge, so say that the field is due to the charge q and we are bringing unit positive charge. So second point is unit positive charge, and this is for the single point charge. Whatever we have discussed, that is only for a single point charge. What will happen? The electric field is an example of a vector field. Why? Because it is due to some charge. The charge may be positive and negative, so it has certain direction. What is the unit of the electric field or electric field intensity? Q. What we got? We got the intensity is force per Q. So unit is force, unit is Newton, and Q unit is Coulomb. So one important unit is Newton per Coulomb. It has another unit that is Coulomb per meter square. But we generally use the unit Newton per Coulomb. So if we have more than one charge, what will happen? Say this is the field and we want to bring the charge Q1 and Q2 in this field. Please, this is the important thing. This is similarly, this is the positive charge and this is the negative charge. We have already told we will take the orange ball as the positive charge and the blue ball in the negative charge. If we want to bring the Q1 in the field and Q2 in the field, what will be the total field intensity? So for the field 1, Q1, it is Q1 by R01 squared, R01 according to the Coulomb's law. And for Q2, Q2 by R02, Q2 by R squared, R02 hat. So what is the total field intensity? Total field intensity is summation of this. This is also known as the superposition of the electric field. If we have more than one charge, we will add it one by one and the total field intensity is the summation of all the charges. Now the last important thing, what are the charge distribution? So till now we are telling about the charge. Is charge is a point or what is charge? We can't see the charge, but charge is everywhere. So we can distribute the charge into the four parts. One is known as the point charge. Till now whatever we have discussed is known as the point charge distribution. The charge are like particles and they are some distinct point or they are some discrete point is known as the point charge. Q1, Q2, Q3, these are the point charge. Next important thing is the linear charge distribution. Think about the overhead lines. In the overhead lines, it is from one area A to area B. So in this line, there are thousands and thousands of charges and we do not know what is the total amount of charge. So we cannot define it due to using the point charge. What we can do? We can check it due to the linear charge. We can take it as the linear charge distribution. We will assume charge has been equally distributed throughout the overhead lines. So this is known as the line charge distribution. You can see this is the positive line charge distribution. This is the negative line charge distribution. This is the circular line charge distribution. But it is according to the line. Next one is the surface charge distribution. One common example is the parallel plate capacitor. In the parallel plate capacitor, when we are connecting the plates with the battery, the charge is distributed on the outer surface of the parallel plate. So this is called the surface charge distribution. And last one is the volume charge distribution. Though we think that when current is passing through our overhead lines, the charges reside on the outer surface, but a minimum amount of charge always will be inside. So for that we will use the volume charge distribution. Charge distributed along the total volume. So first we will discuss about the linear charge density. What is the meaning of linear charge density? First, as we told that the charge has been distributed throughout the line. Charge has been distributed, so it is written by rho L. This is written by rho L. This is the rho L is known as the linear charge density. And what is the meaning of linear charge? Charge per unit length. What is this? This is nothing but the charge per unit length, and we can write it dq by dl. We can write it dq by dl. Charge per unit length. And what is its unit? Its unit is coulomb per meter square. Now how to get the charge? If we know the charge density, so from here we can write dq is equal to rho L dl. So if we integrate both sides along the line, we can get the total value of q. So q is equal to rho L dl integration of the rho integration in a, this means it is in a closed path. It is a closed contour integration. Q is equal to rho L dl. Now what is the when we can get a sharp beam in the cathode ray tube or a charged circular loop conductor, we can get the examples of line charge. In the case of the CRT, when the charged particles come out, we can tell it as a example of line charge density. We will integrate along the line. So if as it is along the line, if it has only single dimensional, and integration will be one time only. This is the one important thing to remember. While we are calculating the charge from the linear charge density, we have to do the integration only once. Next one is the surface charge density. What is the meaning of surface charge density? If the charge is in the surface area of the conductor, the general tendency of the charge is to lie on the outer surface of the conductor. So if we know the surface charge density, we can calculate the total charge. So surface charge density rho S is equal to dq by ds. And what is the unit? The unit of charge is coulomb and the unit of surface area is meter square. So the unit is coulomb per meter square. And how to get the charge from here? Again, dq is equal to rho s ds. So if we integrate both sides, q is equal to rho s ds, and it is a surface integral. We have to integrate along the surface. Last important thing is the volume charge density. What is the meaning of volume charge density? Volume charge density means if the charge is not evenly distributed over the volume of the conductor, we called it as a volume charge density. Sorry, this is the volume charge density. Volume charge density. So, what is the meaning of the volume charge density? If the charge is, as I told, the general tendency of the charge is to stay on the outer side of the outer surface of this, but little amount of charge always reside inside the conductor. So if we charge is not equally distributed, we can calculate it by the volume charge density, and for the later portion, volume charge density is very important thing. What is the meaning of volume charge density? Volume charge density means dq by dv, number of charge divided by number of volume. So what is the volume? Volume means we can write that dq is equal to rho v into dv. So if we integrate it, we can get Q is equal to volume integration of rho v dv. As dv has means x, y, z, 3 axes, it should have 3 integration. So line integration means 1 time integration, surface integration means 2 time integration, dx, dy. And volume integration means 3 times integration, dx, dy and dz. Now if we have to calculate the field intensity due to charges. So what is the basic formula? We know intensity E is equal to Q by 4 pi epsilon r square AR. So this is the basic formula of the intensity. Now, when we are if this is a line charge, say this is the overhead lines, this is the small area dl. If we want to calculate the intensity due to the line, what will happen? So r is the distance of the point. What is r? R is the distance of the point at which we want to calculate the intensity, and this is constant. So what is, we have to only our unknown thing is the Q, because as this is a overhead lines, we don't know the actual value of the Q. How to calculate the Q? So the formula of calculating the Q is for the line charge rho L dl. What is Q? Q is nothing but the line integration of rho L dl. So what is the meaning of rho L? So what is the meaning of rho L? Rho L is the line charge density. So what will be the E? Instead of Q, in the place of Q, we are putting here rho L dl. So E is the line integration of rho L dl by 4 pi epsilon 0 r square AR. So this is the field intensity due to the line charge. Next, similarly we can calculate the field intensity due to the surface area. How to calculate it? The procedure is the same that we already know. That you can see this is the surface, and the surface is full of positive charge. We are thinking about a small cross-sectional area, and we want to calculate the intensity at a point P, at a distance point P, and the distance is R. So what is the formula? The formula of intensity, that is constant, Q by 4 pi epsilon 0 r square AR. That is the constant formula. Here also we have to calculate the Q. So how to calculate the Q? If we know the surface charge density rho S, so Q is equal to, what is Q? Q is equal to rho S ds along its surface. So we can see here, so dE is equal to dQ by 4 pi epsilon 0 r square AR. What is dQ? dQ is nothing but the rho S ds. Now rho S is the surface charge density. So if we want to calculate the totally, we have to integrate it, surface along the surface. And as this is the surface integration, so we have to do the integration 2 times. one with respect to x, another is with respect to y, or it may be yz, it may be zx. Similarly, we can calculate the volume charge density. Similarly, we can write what is intensity, dE. dE is equal to dq. You can see this is a volume and we are taking a small volume here. This is a small volume we are assuming. And so according to the Coulomb's law, dq is equal to 4 pi epsilon 0 r square AR. Now what is dq? dq is nothing but the rho v dv divided by 4 pi epsilon 0 r square AR. Now if we integrate both sides, we will get E is equal to rho v dv volume 4 pi epsilon 0 r square. R is the distance from the small, this is it looking like big, but it is a small area to the point P. This is our r square AR. So already we have discussed, just a quick revision. In this chapter, we have discussed about the charge, what is charge. Next, we have discussed about the Coulomb's law. Then Coulomb's law in the vector form. In the Coulomb's law in the vector form, we have to remember the direction as AR. Then we have what we have discussed then? Then we have discussed about the superposition theorem. Superposition theorem means the force for the of any point is due to the summation of the force due to the each point. If we have to calculate the force on any point, we have to make the superposition, means we have to add the force on for the individual point. Then we have discussed about the field intensity. What is field intensity? The work done to bring one unit charge from infinity to one electrical field. And what is the equation? E equals to Q by 4 pi epsilon r square. What is epsilon? Epsilon is nothing but the permittivity, and epsilon value is epsilon 0 epsilon r. Epsilon 0 is the relative permittivity. Epsilon 0 is the permittivity of the free space, and its value is 8.854 into 10 to the power minus 12. Epsilon r is the relative permittivity. Next, we have discussed about the different type of charges. Line charge. First one is the point charge. Next, line charge. Next is the surface charge, and fourth one is the volume charge. Next, we have discussed about the line charge density. It is written by charge per unit line, and unit is coulomb per meter. It is written by rho L. Next, we have discussed about the surface charge. Surface charge means the charge per unit surface area. Charge per unit surface area is known as the surface charge. We will write it by coulomb per meter square. And third one is the volume charge. Volume charge we can write it by charge per unit volume. Its unit is coulomb per meter cube. Then we have discussed about the intensity due to line charge. The formula is E is equal to rho L dl 4 pi epsilon 0 r square AR. AR is the direction of the force. Next, we have discussed about the surface charge area. In the surface charge area, we can write E is equal to integration of rho s ds 4 pi epsilon 0 r square AR, where rho s is the surface charge area, surface charge density. And last, we have discussed about the volume charge density. What is the meaning of volume charge density? Rho v dv, and intensity is rho v dv 4 pi epsilon 0 r square. And what is AR? AR is the direction or unit vector along the radius. So this is the today's class. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.